got and what you're looking at here are two different scales. Well, let me do this. The maximum flooding surface is going to be the surface that is the shaliest. Excuse me, the maximum flooding surface in the condensed section associated with it is going to be the one that's the shaliest, and that's this one right there. Whoops. I couldn't draw very well. It's this one right there. So that's your maximum flooding surface. These are flooding surfaces, the other shales, but they're not the maximum. The maximum one is, remember, that's the most landward extent of the shoreline. So it's going to be the shaliest. And it'll have organic material with it that gives it the high gamma ray. Well, what's happening below that maximum flooding surface? What would you expect to happen below? According to the model here that we've been using, you would expect to find transgressive or regressive below. Transgressive, okay. And the way that transgression is expressed here is by variations in thickness. So you've got a thick one here, a little bit thinner here, and thinner there. Cartoon to explain that is right here, where you drill a well. So you have a well right there, and you've got a period of progradation that pushes the sand out here, and then you've got a marine transgression that brings the shale landward, and then you've got another progradation. But the second one didn't go out as far as the first one. So then you have another transgression with you deposit shale and you have a flooding surface associated with it. And then another period of progradation. But this one didn't get out as far as the one below it. Then another transgression, another flooding surface. And then another progradation that didn't get out as far as the preceding one. And that's expressed then as the expression of that would be in this well, you've got thicker, getting a little thinner, thinner, and thinner. And that's exactly what you've got here. Thicker, somewhat thinner, and thinner. So, what's happening is each progradation is not getting out as far as the previous one. So overall, you've got a transgression with these higher frequency intervals of progradation. But overall, a transgression. Now, your maximum flooding surface, again, is right here. What's happening above that surface? Well, try this color. You've got a thickening upward package. Here you've got a sand, and it says a flooding surface, but you just see a little shale, meaning that you've got a shale there, it's just not thick enough to be resolved by the log. So, you've got a relatively thin sand, little shale, a thicker sand, a little shale here, and an even thicker sand up there. And what is that? Well, that's, now your well has drilled through here, where you've got progradation, transgression, progradation, but this one is going out further than the preceding one. Transgression, progradation, transgression, progradation. And each subsequent progradation goes out further than the previous one, meaning that overall, this sequence is a regressive sequence or a progradational sequence. And your maximum flooding surface is going to be right there. Okay? Now, what have you got in the sense of geological time? You've got two scales of time, of geological time. One scale that represented this transgression, turnaround, and then regression. That might have been what I called yesterday a third order cycle, for example. Over an interval of time, maybe 10 million years, something like that. But superimposed on it is you have this higher frequency cyclicity. That might be like a fourth order set. And this is really what's controlling your reservoir when you get down to this level here. That's why what I said yesterday was that when I'm doing sequence stratigraphy, I kind of like to work at the third and the fourth order scales because you can understand them. And if you try to go to a higher frequency, like a fifth order scale, you often can't see the differences very well because they're so thin. So now you're all sequence stratigraphers. You've successfully shown that we've got two scales of systematic scales, transgression, regression, maximum flooding surface is that point where it turns around. That's at the, we'll say the third order scale, and then at the fourth order scale, say at the fourth order scale, we have our sea level curve would look something like this, going like that, superimposed on that third order scale. Okay. Well, what's the significance of knowing this? Who cares? You know, it's great for us academics, but does it really mean anything? Well, it does, because what this is telling you now, if you can develop that stratigraphy in the one well log, you can now predict what's going to be away from that well log. In the case of down here, the case of the transgression, what's going to be to the left? You're going to have this sort of stratigraphy. You're going to get to the left of that well, you'll get these shoreline sands, which are shown in yellow, and what is shown in green are your floodplain deposits. So what this is telling you is that this, for this part of the interval, off to the left, the further up the section you go, the further away you're getting from your fluvial deposits, the green ones, your floodplain deposits, and the closer you're getting to the edge of your progradational shoreline deposits. What can you predict about what's going to be to the right of the well? Well, you're not going to have much sand there, especially in the top part. This one here is probably going to, do this another way here. This one here is probably going to pinch out into marine shale, right about there maybe. The next one's going to be going further. So you got more sand off to the right, and this will go even further. So you've got even more sand off to the right. What's going to happen up here? Just the opposite. Down below here, this might pinch out there. to the right. You get more sand over here. This one goes a little bit further, so you get more sand as you go up. Okay, so you may, that's what the advantage of doing this is. It allows you to predict what you're going to have away from the wellbore, in this case. And so that's your reservoir characterization within a sequence stratigraphy framework. Something I forgot to mention, then we'll take our break. One thing I forgot to mention, on this one here, this is what we would call a lithostratigraphic correlation based on the characteristics of the rocks. Remember, I defined lithostratigraphy early yesterday morning. This would be your chronostratigraphic or your sequence stratigraphic correlation. Okay, so this is the best example I know that shows the difference in your correlation patterns, whether you look at the rocks lithostratigraphically or sequence or chronostratigraphically. Different correlations completely with different effects, in this case, with different effects in your water flow. Well, okay, why don't we take our break and just about finished with sequence stratigraphy. One more little thing and then we'll talk about resource shales next.